Here's a typical easy question. It's bouncing here, and it cuts through there and there. And this is going to be at 1. This is going to be at 4. This is going to be at -2. You should be able to write me the equation for this polynomial. It's got a double here. And these are both singles. They are not inflection points. If they were, they could be a triple. Write an equation for that one. Okay, please compare it with the person next to you. Okay, Hakan, can you tell me what you put?
Y equals x plus 2.
X plus 2.
All in parentheses, and then x minus 1.
X minus 1.
X minus 4 squared.
And x minus 4 squared. Did you even think about the fact that that was going up?
I did, and I didn't put a negative.
There, very good. If you didn't even think about whether it ended going up, you probably would have forgot if it was going down to put a negative. So you always have to look for that, because you don't know if it's negative in front or not unless you look for that. And that one's positive, so of course we don't need a negative on this one. All right, next up is, what if I just gave you one that's comparable to that, but I asked you for the real and imaginary solutions? Hint, there's 2 real ones and there's 2 imaginary ones. I'll pause for a second. If in case you forget, you'll end up with the square root of a negative on the imaginary ones. That's what makes it imaginary. I'll pause while you try to find me the real and imaginary solutions here. Okay, and I heard some kids talking. This was the easy one. X equals -4, that's real. X equals 7, that's real. But this one, they solved by setting it equal to 0, and then making it x squared equals -3, and then square root, and then one of them caught it, and one of them didn't, that there is 2 answers to this. Because of the absolute value, I bet you if you remembered that much, you'd probably remember that there's 2 answers. Plus the square root of -3 and minus the square root of -3. And if you left it that way, that'd be really sad. Both of these kids knew it was I root 3. There's your 2 answers. Do you want to practice that, or you feel like you got that down? How many of you had it right in the first place? That's almost it. Okay. All right, those are the imaginary solutions. Sure, you can say plus and minus I root 3. And I know some of you forgot the plus and minus. It's just a lock that somebody's going to forget. Oh, yeah, this is the absolute value, which has 2 answers. Okay, next major concept is, what if I, instead of giving you the graph and asking you to write an equation, what if I tell you stuff and you have to make the graph? It's got a double root at 3, a single at 0, and a triple at -4. The lead coefficient is negative. Make me the graph. If all of these things are true, I got a double root at 3, single root at 0, a triple root at -4, and the lead coefficient's negative, you should be able to draw the graph. I'll pause for a sec. Okay, so I'm going to just put big black dots where there has to be x-intercepts. One of them's at 0, one of them's at 3, Another one's at -4. Okay, and the lead coefficient is negative, means it has to go down at the end. All right, so the one that's at 3 is a double root, so then that bounces there. Single root at 0, that means it just passes through there, and it's not an inflection point, otherwise it would have been a triple. A triple at -4 means that I need to make this be like an inflection point. Now, if you're not confident of your skills in making that be like increasing at a decreasing rate and then changing to an increasing rate, you could just label it as INF for an inflection point, or you could even say that that's a snake. I would have been okay with you telling me, hey, Mr. Server, I'm trying to make it one of those triple roots. Okay, so does mine have a double root at 3? Yep, there it is. Does mine have a single root at 0? Yep, it's just passing through there. Does mine have a triple root at -4? Yeah, because I even labeled it. Made it really clear that that was a triple root. And my lead coefficient being negative meant it was going down on the end. Yours should have looked similar to mine. Any questions about this? If you think I'm wrong, please say something. Anybody think I'm right? Okay, good. Almost everybody's agreeing. All right. Next one is, do you remember synthetic? So I'm going to give you a problem. X to the 4th plus 3x to the 3rd, let's say 3, plus 6x squared plus 12x plus 8, and then I'm going to say x plus 1 is a factor. You can use that. I personally would use synthetic because long division is kind of hard. Synthetic's way quicker. And the directions would say factor it all the way. Like, not just factor out the x plus 1, factor it all the way. I'm going to pause for a second while you give that one a try. This is all from the test that would be called the higher degree polynomials part, which I said was the hardest test of the year. All right, just to make sure you're setting it up right, you should have had a -1 over here, and then you should have copied down all the coefficients. 1, 3, 6, 12, 8. Did you even think about placeholders? This went 4, 3, 2, that's a 1. I didn't need any placeholders. Do you get if there would have been a missing term in there? Like if it went 4, 3, and there weren't any x squareds, and then there was a regular x, you'd need a placeholder of a 0? Just a reminder, that's a thing. Okay, so drawing this line, technically what you're doing here is adding nothing and getting 1. I say drop it like it's hot. Then you multiply. Then you add them. Then you multiply. Then you add them. Then you multiply. Then you add them. Then you multiply. And then you add them. It ended with a 0. That means it worked. Yay, the remainder is 0. That means I have an answer. And it is x plus 1. Very easy to goof that up. And then this part here, that's the constant. Then the 4 is about x's. There's no signs, so it must be all positives. Then it's 2x squareds. And then this is x to the 3rd. Did anybody notice that it could factor again? All right. Now I know some of you are like, well, that's going to happen. You're going to forget to factor it again. This one is a factor by grouping. And so I'm going to leave this x plus 1 here. And then this part, I personally like to just like show what I'm doing. You do not have to have this because you could do it all in your head. But I'm going to factor out the x squared here and have x plus 2. Factor out the 4 here and have x plus 2. And then bringing the x plus 1 down again. Then this is the common factor. Comes out to the front. No, you don't square it. Because the reason there's 2 of them is because you distribute this whole thing to this and to that. That's how there's 2 of them. And if you thought you could factor x squared plus 4, again, you're wrong. Because that kind only factors if there's a minus there. So this is factored all the way. How many real answers did it have? 2. How many imaginaries? A lot of people are saying 1. Here's why it's not. When you solve this, you get 2 answers. The fundamental theorem of algebra says that whatever the power is, that's how many answers there are. This has 2 answers. They're just both imaginary. So there's 2 imaginaries, plus and minus, and I can do it in my head if I really try hard, 2i. I'm pretty sure I'm right on that. And then this is -2, and this one's answer is -1. These are real. Those are imaginary. Okay, intense test. Now, what about the test that we just took the other day? That one's called rationals. Well, you obviously have to factor. It's all over. Every single problem has factoring in it. But let's say, I think this is the most representative of kind of a normal one. Everybody write this one down. There, I have factored it all the way. On the bottom, sorry. You got to factor the top. Then you would be asked many different things. One of them could just be, is there a hole? And spoiler alert, there is a hole. You got to figure out where that hole is. Horizontals, those are the kind where you go way to the right and you see if it's leveling off somewhere off in the distance. Is there a spot it keeps on getting closer and closer to? That's the 1000 idea. And then the vertical asymptote, that's just whatever made the bottom 0. And the last thing I'd ask is make an XY chart and find me the 2 key points. Once you put the asymptote in there, it kind of informs you that you should go a little on either side of the asymptote. All right, this is the hardest part of the rationals test. Let's just make sure you didn't go too far off on the whole factoring thing. I hope you factored the top. They both had a 2x in them. And what you should have left is 2x plus 1. When you factor out a 2x, you get 2x plus 1. The way I can tell that's right is because if I multiply it back out again, I'll get 4x squared plus 2x. Then, the thing that cancels, I'll highlight it, is right there. Now, you're not used to having something like that cancel, but that does cancel and it makes the whole. But it's not just a simple like -1 makes the whole. What does make the whole? Zina, what do you think it is?
I got -1/2.
-1/2. And I can prove you're right because if I put in a 1/2 right there and then make it a negative on either the top or the bottom, the 2's cancel. I'm left with -1 plus 1, which makes 0. Yep, -1/2 is the x value of the whole. Okay, there's like some really loud people in the hallway. You have a question? And Carter, could you shut that door, please?
Can you use decimals too?
Sure, -0.5 is just fine. Now, I need to cancel this out and write what I actually have left. And this is gone because I factored it. So then I'm going to just put it on the other side of the y here. two x's on the top, and on the bottom I have x plus 5 left. Why is that important? Because that's where you'd put your negative a half, back into the simplified function. And so 2 times negative a half, well, half of 2 is 1, and then you make it negative, is negative 1 over 1/2 plus 5, well, that's 4.5. I know this isn't awesome because it's got a decimal inside a fraction. On your test, it would very likely just come out to a nice clean number. If you wanted to know, this is like negative 1 over 9. Half of 9 is 4.5, right? And when you flip that, it'd be negative 2/9. I don't know if anybody actually did that, but this is fine for now. Don't normally leave decimals in your fractions. That's what it actually would have simplified to.
What is the 2x when we took it out of the 4x squared plus 2x?
Yep,
That-
this 2x right here.
Would we not plug that back in to get the whole? Or
That's what I got right here. This is where the 2x is.
okay.
And then we stick the negative a half in. Because it's what makes this part 0, that's the x of the whole. So the negative a half goes into the 2x, right there. Okay, now horizontal. Horizontal is the 1000 idea. I'm going to take this equation, I'm going to rewrite it, 2x over x plus 5. And stick in 1000 to see if I go way to the right, what happens? And I hope you know that 1000 plus 5 is pretty much 1000. And then, this is really critical. If you see that you can cancel them, you should. The thousands cancel. I'm left with y equals 2. Raise your hand if you had y equals 2. Yay. And the vertical is whatever makes the bottom 0. Our equation has an x plus 5 in the bottom. So x equals negative 5. That, in turn, goes on to your chart. X is negative 5 is the asymptote, and that tells you you'd be really smart to put in negative 4 and negative 6. If you haven't already, I would do that. I'm going to rewrite the equation. It's 2x over x plus 5. That's our simplified equation. No point in putting in negative 5. It doesn't work, and that's why it's an asymptote. But putting in negative 4 makes negative 8 over 1. These always work out for some sort of magical reason. And if I put in negative 6, it becomes negative 12. Double checking myself here. I think I did something wrong. Hold on. I'm going to put my negative 4 back in here. I know I did the bottom right, but I think I did the top wrong. Okay, so the bottom comes out to 1. The bottom comes out to 1, but the top isn't 1. The top is negative 8. The bottom is 1. Negative 8 divided by 1 is negative 8. Sorry about that. And now I'm going to stick in the negative 6. And I have negative 12 over negative 1. The negatives cancel. Double checking 12 over, yep, it's just 12. And now I'd be able to graph it because I'd have asymptotes that I can graph. And actually, this part is super easy. I'll just do it. Y equals 2 is the line that goes across like that. X equals negative 5 goes like that. And then I'd have an asymptote at, I already did that. And then I'd have a point at negative 4, negative 8. That's like way down there. And then I'd have a point at negative 6, 12. And that's like way up there. And that tells me it goes like this. And it goes like, well. And it goes like this. And what mistake did I make that tons of you also made? I forgot to put in the hole. There was a hole way back here. There was a hole at negative a half. comma, negative 2/9. That's basically right about there. There was a hole, and it's so easy to forget. All right, so now we have practiced pretty much everything. Not an easy test. And this is our extra review day right now. We've had 3 days of review for this cumulative. That is more than you would normally get. I just happened to be ahead, so yay, we had time to do that. But now, in the last half an hour-ish of class, you don't have that much left. But anyway, I'm going to give you your test back again, and you can make corrections. And the main thing is, do you understand what you did wrong? Because you don't want to just make the same mistake on the cumulative, right? So ask friends, come up and ask me, just to be a nice, happy work time. And what if you're getting an A? You don't even need to correct anything. Well then, I've put a folder in Schoology with a bunch of extra practice problems. That worksheet we've been working on for the last 2 days, that's an assignment. You have to do it. It goes in the grade book. Do it. I hope you already did it, or at least you should finish that. But there's a blue folder in there that says for January 10, extra practice problems. You can go in there, and if I were you, I'd pick out a couple easy ones just to kind of build your confidence, and then I would try the ones that scare you. They're divided up into R2s and R3s. Obviously, the R2s would be easy ones. I would pick a few hard ones and challenge yourself. Let me give you one last reason to study. You have some grades going, whatever this one was, whatever this one was, whatever this one was, and then on their last 2 tests, let's say you had an A, but let's say you also had a C on the last 2 tests. And now you're about to take the cumulative. Do you get, if you don't study for this cumulative, you might get a C again. And ending the semester with 2 C's would really tank your grade. Do you get that if instead you get an A on this test and you've done corrections, you could change it to 2 A's instead of 2 C's. It's a big swing, and it all depends on the next 24 hours. Okay? 24 hours from now, you'll be in the middle of that cumulative test. Be nice to yourself. Study for it so you can end this semester strong. Cumulatives are huge. All right, and that's all I have for you for today.